sorry, if you're going to just do one project yourself and that car's reliability is kind of like a medium ground, then you can get away with buying the we'll call it like the knockoff tools off of Amazon from guys like JR Ready. Um, really want to discourage that though if the car's fast enough that someone could get hurt, that you're going to be running traction control type systems where the crimps on the traction control system are really important. Um, so, if the car matters to you at all, it's really worth the investment to buying at least two tools. So
Green flag, green flag.
Welcome to the Blind Apex Podcast, where amateur club racers tune in to get faster.
Forgive any of the audio that you hear in here. It's rescue off the cloud. We did our best to try to get this synced up and edited correctly. That being said, this episode is brought to you by Deechworks Fuel Systems. Visit deechworks.com for all your fuel system needs. If you want to support the podcast, please share or go to buymeacoffee.com/the Blind Apex Podcast. Now that business is out of the way, back to the program. Now that business is out of the way, on this episode, we're going to talk a little bit about wiring, maybe some Motec, maybe some Lotuses. I don't know. We'll see what we get into. But since I'm colorblind, I probably shouldn't be trusted with a set of crimpers, and I don't know my way around a voltmeter. So, unless you want to fire, then you can let me do it. So joining me, owner and operator, FastX Autosport out of Texas, the shop behind the 1,000 horsepower Lotus Elise Super Lap Battle car. At this point, it would have been about a month ago, a little over a month ago. I'm 100% sure he believes in anything worth doing is worth overdoing, because he claims to have 20,000 invested in wiring tools and supplies. And now I could probably do that just on my Amazon cart, but we'll see. Building custom harnesses for whatever you want. Kevin Fennel, welcome to the podcast, sir.
hey, thanks for having me on.
Yeah, so you guys are in Texas. Do you guys do a lot of like Texas 2-mile cars or Texas mile cars?
So we actually have only got one of them ever into the shop because, we started off with our reputation being Lotus, and I'm sure as time goes on, it'll turn into more about just building fast cars. But we've got a Mustang that was a mile car. Now it's a Big Bend open road car, and the owner kind of goes back and forth a little bit, but it's given us some exposure to what those cars look like, because it's just all horsepower and none of the suspension and aero stuff that we're used to dealing with.
Yes, I think I commented on some post of yours a year ago or so on Instagram. And then I was like, you know what? They build crazy harnesses and stuff. I should get them on about wiring. But you guys are busy. So can you talk to me about this 1,000 horsepower Lotus that you have going on?
Yeah, so one of our good customers was just kind of talking to me one day about what we wanted to do next for them in racing. And I'd been wanting to build a Super Lap Battle car, and they didn't really know what they wanted. So I got them to actually come out to Super Lap Battle in 2024. We saw the event. They saw that it was, in terms of spectator events in the US, I'm going to guess it's the biggest amateur event, but I don't know for sure. And they're like, yep, let's do that. Let's build that car. And it was a big leap of faith for everyone, because we weren't really sure how fast the car was going to be. And all we knew was that my car was doing about 17s on Hoosiers with 250 horsepower. So I figured, getting into the 12s would be doable with a lot more power. So
And this is at Coda, right?
Yeah, at Coda. Sorry. And we went back and forth a little bit about what engine we were going to put in it, and we decided to go with the 2GR because the builder, what's kind of not like quote stand behind that it would make 1,000 horsepower for a lap of Coda, and we couldn't find anyone that would build a K24 that would say the same thing essentially. Which definitely like makes me ask some questions about how some of the other guys, like the Skura guys, are running 1,000 horsepower K24 when no one in North America will say, "Yeah, we can build that." But I guess we'll find that out in the long term how those cars actually work out. Um, but some info about that car. So it's we went with the 2GR. It's a twin turbo. It's got a 7-speed sequential Cowtech transmission, which many people will be familiar with from the Corolla GRs. So
Mm-hmm.
that thing uses the same sequential internals as the Corolla GR all-wheel drive transmissions, which I always think is kind of funny. It's on Motec with a PDM in the front, a C12 dash with rear view monitor, a C1212 dash, sorry, an M150 GPRP Pro ECU, and another PDM in the back, which was really, really nice for making the wiring simple. So now there's no power running the length of the car, really. And you know, the rest of the car, apart from the engine and the control system, is really quite pedestrian. It's just the same Elise parts suspension setup that's on my car. Penske 7500 doubles, the same as on my car, and uh, a plywood front splitter with plastic splitter amps, and yeah, it and it just happens to all work together really well. So we were able to, in the limited number of laps that we had, get it to, be in the aero window, be in the right power around the track, the traction control working just right, and so on.
Yeah, we're big believers in plywood splitters around here. I I actually have to make one this week, assuming I can get my car started. But yeah, it's I I think everybody should use it. If you're going down the carbon fiber route, like it, man, you got buckets of money laying around.
Yeah, so just so people are aware of like what the Delta really looks like, we had 3 splitters cut and shipped to us for maybe $1,400 total. And the price to get a single 3D carbon splitter from one of the big aero companies you heard of is close to 20,000 for the first one and like 8,000 for the second one.
Yeah, and well, we're really big on cut your own. Get out the jigsaw
Mm-hmm.
and and get it all done. But I still that delta's kind of huge, right?
Yeah.
It's a
And you can't make your own
30
splitter
to
for
1,
less than
30 to 2.
$400 if your time has any value as well, too, right? So even getting them cut for $400 a piece is probably um still cheaper than making your own, even in my opinion.
Oh, yeah, for sure. Assuming you can send them the right kind of template or
Yeah.
the drawings. I live within crazy rules that say you can't see it poking out when from the bumper when viewed from above. So it's sort of like okay. Yeah, it's small for my car anyway. But lips don't the protruding lip doesn't do all the work. So
No, correct. Like
we
having
also know.
having the flat area that you can create low pressure under is kind of the secret there, right? So whether that's
Right.
from rake of the car or diffusers or whatever you can do on your car.
Yep, for sure. So let's talk a little bit. You talked about PDMs, you talked about the Motec setup in this car. Let's talk about some of the basic tools we would need if we were going to tackle this project.
Mm-hmm. Yeah, so just getting started in wiring, like if you're gonna wire just one car for yourself, um, and that car's reliability
Nope.
is only like have I muted myself? No? Okay, it said I had. All right, sorry. If you're going to just do one project yourself and that car's reliability is kind of like a medium ground, then you can get away with buying we'll call it like the knockoff tools off of Amazon from guys like JR Ready. Really want to discourage that though if the car's fast enough that someone could get hurt, that you're going to be running traction control type systems where the crimps on the traction control system are really important. Um, so, if the car matters to you at all, it's really worth the investment to buying at least two tools. So one of them would be the DMC,
Mm-hmm.
the TH1A, I think, the big DMC three position turret crimper. And that lets you do all of the DTM connectors. And the nice thing about those is that there's now Motec connectors that use the DTM crimp style from ProWire, and then there's another set from Race Spec that use a different crimper, but you don't have to have a specific um, W style crimper for the Motec pins anymore. And so really you could do quite a bit with just that one turret setup. And then you need the closed barrel crimp tool, so the one with the yellow handles. I guess I could have looked these up before we started. Let's see here. So the closed barrel crimper images. Well, that's all you're getting from me. You want the yellow one, but
Yeah.
but what it does is it crimps size 22, 18, 12, and 8 gauge
Mm-hmm.
closed barrel crimps, and that's like really the secret to making it a nice harness. Is everywhere you've got your one 5-volt signal coming to a junction point, and then you split that out into 7 different spots. So if you're trying to crimp that with like a W style open barrel crimper, or solder that together, like God forbid, or whatever, like the discount ways to do that are, you're going to then have a sensor that doesn't work in 6 months, and trying to find where that crimps come loose inside the harness is just, it's not fun at all. So getting that crimper was like the big turnaround in my wiring, progression from being a bad amateur to a good amateur. And then from there, moving your way up slightly through the specialty tools to have a crimper for the smaller DMC crimpers for each size of terminal you're going to do, and then adding turrets for the Autosport stuff when you think you're ready for doing Autosport. And then the heat guns are also important too. So I just started with a DeWalt digital heat gun, and then moved on to, actually, I think I moved down to like an Amazon heat gun after that, but I was having a lot of trouble. You'd set it to 800 and it would start there, and after a few minutes you'd be burning through something that should have a 1200 degree burn point. And so then I switched to the nicer digitally controlled industrial heat guns, which are really nice, and then made a little pocket for it so it sits under my desk so I'm not burning myself on it all the time. I think people really undervalue the importance of like setting up your workspace nicely.
Mm-hmm.
So if you saw the YouTube or Instagram video about the wiring room, you can see that there's, the wires are right beside me, the heat gun's under the desk right beside me. All of the tools have a shadow foam area on the other side of me, and I never have to move once I start working on a harness like that. So that's really important, I think.
Yeah. Oh, could you imagine? I mean, I'm sure you've had to tackle some like major harness repairs outside,
Oh,
in the
I don't
shop.
I
But
don't like
could you
it.
imagine? Oh yeah, I'm for sure about that because I mean, I'm fighting my harness. I pulled my OEM engine harness and put a new, well, not a new, but one out of a known running car in just to make sure I eliminated that today. And I was like, oh, I can't imagine having to build one of these out here in this garage. So,
Yeah, fortunately, like the biggest thing we ever really do, even like on a car in the air conditioned garage, is to maybe cut off the OEM wiring harness plug on a Lotus and replace it with an Autosport connector, or with the drive-by wire connector, so you can actually make adapters.
mhm.
But apart from that, yeah, it's just small repairs in the shop, and then harness builds all get done at the desk, carry it out, measure, bring it back in, kind of deal.
Okay. So, you mentioned Amazon, and I don't think a race, well, let's say, I say this all the time. I don't know how race cars got built prior to Amazon Prime.
Well, on the wiring world, they probably got built better because you like don't take what I said about buying stuff from Amazon to don't let that influence you, because if you buy stuff on Amazon, you're going to get fake products like 100%. Especially Deutsch connectors. Definitely,
Mm-hmm.
definitely never buy them on Amazon. They're going to be fake. And then you put one of those fake ones on a cooling fan, and you get the startup surge voltage through them, and now you got a fire.
Oh, you're going to make me go buy another kit.
Hmm.
S- uh, eh, so let's talk about supplies like connectors, wires, those type of things. What are some reputable sources for that stuff?
Yeah, so I actually buy 99% of everything from two people. So ProWire is where I buy 75% of my dollars, I'd say. And just because I get everything from them in a day versus RaceSpec is 3 days, or
Okay.
5 days maybe. It just depends. But a lot faster shipping, slightly better pricing. Not really very different at all. But RaceSpec and ProWire are fairly similar there. And then there's a few things that I use a lot of, and I've got the regular part number from that I buy just directly from Mauser or like a DigiKey type place. So some examples of that would be the AIM PDMs. They come with terminals that only crimp down to 18 gauge, I think, or 20 gauge,
Mm-hmm.
and but they make a terminal for that connector that crimps down to 26 gauge. And so I buy by the thousand those connectors from Mauser, and they last me for 20 AIM PDM installs. Like I've never run out of them before. So there's a little bit of stuff like that. I buy sensors like Honeywell sensors direct from Mauser, probably about half the price you'd pay online. And I'm gonna guess that I could probably get into buying terminals and stuff the same sort of way, but it's at some point you have to draw the line between spending all of your time trying to save 3 cents and calling a guy that answers the phone and says, yeah, like I can overnight that to you, or I can help you solve your problem. So it's good to have that relationship.
So I want to get into some potentially controversial topic here. Uh, what is your opinion when you read the term mil spec when you're looking at things?
Yeah, like to me that means one specific thing. It's like the kind of connector that uses the DTM style pins in silver or black. Apart from that, I don't really use that or always know what other people are talking about when they say it. I guess I occasionally will use it when we're discussing, like, do you want a mil spec harness or do you want an Autosport harness? Like in reference to how we're going to do the bulkheads and stuff. But it's not really controversial to me because I kind of came from outside the industry and don't have any baggage like that.
Well, so let's talk about the difference between the mil spec and the Autosport.
Yeah, so the mil spec connectors are good connectors. They have fairly high density. The terminals are easy to use. They're easy to plug together and stuff. Um, they're going to be heavier, bigger, and the booting situation is going to be a lot bigger than an Autosport connector. So the Autosport connectors have the boot lip like natively built into the connector. So when you put the
Mm-hmm.
sealed back shell on them, they're a lot lower profile and it's a lot more reliable because you don't have a threaded connection to also fail. So you get a higher pin density. So, if you have a 1 inch circular connector, just gonna say some random numbers. Maybe in mil spec 22 gauge, 20 gauge, you could get 30 pins in it, and an Autosport 20 gauge is gonna have 37 pins in it or something. And the Autosports have a higher current capacity for the same size connector, and they are meant to do more cycles of plugging in and unplugging. But
Oh, so that's good to know because I am always messing with stuff, and so I'd prefer to get the longevity out of my connectors because I'm good for breaking those.
mhm. The catch is the
So,
tools for working with the Autosport connectors are just like really, really expensive. You
hmm.
you need a separate trit for pins and sockets and for each size. So to get set up to work with all the different Autosport connectors, you need 2 crimpers and like 10 turrets. And so it's like $1,800 or something. And then the connectors are, starting at $40 per side, going up to $400 per side kind of deal.
Okay.
Versus the mil spec stuff, if you're doing DTM connectors already, then yeah, you just move right into mil spec with the same tools.
So I race, a lot of us race old Hondas. Okay. Mine's not as old, but it's still long in the tooth. It's probably a 17-year-old car, right? So we generally try to stick with OEM because these aftermarket companies that produce harnesses for us, they don't always last, right? So uh in the OEM harnesses tend to hold up pretty decently. I mean, they at least take a beating and they don't lose amperage and stuff, generally speaking. They do end up breaking, but anyway, what are your thoughts on like using OEM plugs on one side to then build your harness for the rest of the car? Like keep your OEM plug on the lights and then run a light harness off of that.
Yeah, that's definitely fine. Like, so, when we do, say, the Miata endurance builds, we basically did exactly that. So we cut the harness for the entire trunk half of the car off at the bulkhead, put it on a DTM 12 connector, and then when we made the motorsport harness for the rest of the car, then we just plugged in right there and saved a couple hours work. And there's no need to replace any of that. It's worked for 30 years. It's going to be fine to turn the brake lights on going forward. The the thing that you could get into trouble with there would be mostly with the coils. OEM coil connectors, once you're on a race car, they're vibrating, they're getting hot, you've plugged them in, you unplug them 30 times. When you're handling them, they get pulled on probably more than any other connector. That's been a big problem in every platform we've ever worked on or wired custom. So I've actually pretty much gone to a rule where I pot all of my coils and don't use a connector on them at all, and then go to a DTM connector, or put, like on my car, all 4 of my coils are potted onto a harness. So you take the harness in and out with all 4 coils together as an assembly.
Okay.
Which is way, way more reliable until one of them fails, and then you're down completely, right? Because you can't just swap one out easily at the track.
Right. You just have to have a whole spare unit to go.
Yeah, exactly.
Okay. So we sort of talked about this. I don't know whether I want to get into it now. We'll talk about it later. Let's talk grounds, because I feel like my problem is a ground issue. It's either a ground. I'm praying it's a ground, because it's either that or ECU or piggyback is dead. So, what are some good practices for grounding our harnesses or grounding our cars? And can you overground a car?
Can you overground a car? That's a good question. Probably not. But there's like a user ease situation there that becomes really important when you're grinding the car. What you want is for the harness that you're building to really have as few, possibly only one ground point, so that if there's a problem, it's right there. We actually had a problem on the Super Lap Battle car where there was one device that was on its own ground. It was the lambda sensor, and that ground vibrated loose on the track, and we had no idea, and we didn't have an alarm set up for the lambda diagnostics, which, my bad there. But we didn't find out till the driver came back and he's complaining it's misfiring, it feels weird, blah blah blah. Well, come to find out that the lambda sensor had failed, and the throttle was vibrating weird, so it wasn't getting the air exactly the way I was expecting it to. So those two things together made the car run weird. Unfortunately, we got it back together. It wasn't a big deal, but the moral of that is when you're building a harness, try to plan where the grounds are going to be, where it's in a nice, easy spot to work on and to see, and try to have only one ground per section of harness. So the entire engine harness should just have one ground that bolts on to like the top of the transmission where you could see it. Um, and then the chassis harness should have maybe one ground at each end that bolts on to the frame rail where you can see it. And then you want to make sure that the engine is really well grounded to the chassis or to the battery, depending on, if, say you had an Elise, for example, where they don't ground through the chassis super well. Um, run a wire from the battery negative right back to the block, and it doesn't have to carry all of the current, but because you've got the chassis as well, but it'll help keep we'll call it the voltage level of the engine at the ground plane like it should be. Um, so many problems that we find in our shop diagnostics wise are, the ground to the transmission off the chassis is bad. The ground from the coils onto the head is bad. And that's where like having a separate ground for just one thing, it can be really a problem. They could have brought the ground in, or they could have the ground be on the coil like up on top so it's easier to see or something, but there's one ground that's down underneath the VVT actuator, and it's really easy for it to be, tight but not tight enough, or tight but dirty, and it's like almost our main problem on every 2ZZ that's not starting or that's not running well. It's that ground on the side of the head.
So, are are you, if you had a V8 or a V6 or something like a GTR, would you be grounding each side of the cylinder, or like each cylinder head?
So it really depend on what sort of harness we made for that one, right?
Mm-hmm.
So if that's a harness like the Super Lap Battle car where the three coils have their own harness, then yes, we'd have one ground on each side of the head going so that harness didn't have to put the ground through the connector. But if it was just a regular, middle tier motorsport harness where the entire engine assembly was on one harness, then I would probably bring the entire operation to one ground, somewhere near where the V is, and that was easy to get to.
So let's talk a little bit about best practices. So we talk about it when you do research, they always talk about proper gauge. But is it possible to have too big of a wire? Because we know too small is not good, right?
Yep. I mean, too big is just money, space, and weight, right?
Mm-hmm.
The wires kind of double in price about every size you go up. They weigh more. The bundles get bigger. The ability to pass them through bulkheads gets lower, and so on. So, like, absolutely, you could have too big. And I'd say that on a whole car build, if you just went like one size too big on everything, you're talking about close to 20 pounds, maybe.
Oh,
wow. And hundreds of dollars, because now you're going to have bigger pins in your bulkheads going through the firewalls, or you're going to have to split the wires into two to go through the bulkheads, or all that stuff adds up a lot. I kind of wish I knew the weight of the first harness versus the second harness I built for my car, so I bet you would be a perfect example of this. My first harness was probably 1.5 inches, and my second harness was 3/4 inch heat shrink on the main trunk running from the front to the back. So it matters a lot. And then obviously on the other side, you can have too small. You kind of want to size everything and this is just a general rule of thumb, right? So it doesn't apply if you're having a trouble or you're in a very specific certain circumstance. But all of the sensor stuff can be, 22 or 24 or 26, whatever the smallest you're comfortable with working with is. And anything that's carrying current, you want to size it for a 1 volt pressure drop. Do you want me to get into like the math of doing that at all right now, or?
Sure, we can get into that.
Yeah, so every wire is going to have a specified ohms per foot, so the resistance per foot of that wire. And so if the resistance per foot, let's just say it's like zero point 0.1 ohms per foot, and you're going to run a 10-foot wire of 10-foot run of that wire carrying power from the battery back to the brake lights or whatever. So if you know what your so you just V equals IR. Yeah, so you know what your current's going to be, right? And you know what your resistance is. So if it's going to be 1 amp and you've got a 1 ohm resistance, you're going to have a 1 volt drop, right? V equals I times R. Yeah, 1 times 1. And so if you were going to run, and so 1 amp would be fine. But if you're going to run 2 amps through that wire, you'd have a 2 volt drop. So that would be too big. So you'd have to go to a wire that gave you only half an ohm per foot of resistance or less.
Okay. I would be crazy and just do whatever the size the OEM spec was. But when you're talking about stuff like wiring PDMs and things like that, it changes, right? Like,
Yes, you can generally use way smaller wires than the OEMs use if you're using Tesfel or like a really good quality wire. So here's one thing I'll have to add here. I've only wired with Tesfel, and so the Tesfel current carrying and resistance per foot is fairly low compared to a normal wire, and
mhm.
so I'm almost always going quite a bit smaller than OEM. And things like a Honda fuel injector, the OEM is probably 18 gauge. Um, those those wires like could easily be 20 gauge, can probably easily be 22 gauge because they're only firing for such a small time, and all they're doing is driving a coil. There's a little bit of a peak current spike, but once the coil is energized, the current goes down quite a bit. And I know there's high-end race cars out there running 22 gauge Tesfel to injectors and coils and stuff when the OEMs were 18 and 16 gauge and like really thick insulation wire.
Okay. No, I just, I don't know. I'm a noob, so I'm glad you answered that question. And there's math to be done because I'm always
Yeah.
down for some math. So,
Yeah, so the math's a good way to do it. There is also like tables that give the maximum current for like a couple different lengths of Tesfel wire, but those tables end up being so conservative because they're meant for airplanes. So like, yeah, we don't want any heat inside the wiring bundle of the airplane, but if we get a little bit of heat in the wiring bundle in our 20-minute session sprint race car, then nothing really bad of that's going to happen.
okay. Um, let's talk about butt slicing and joining wires all together. I'm gonna assume the vampire connector setup is completely out the window for you.
Yeah, so I kind of touched on this earlier with the tools. Like one of the first two tools that I suggest getting is the closed barrel crimp tools. So you can
Mhm.
use the good Raycam closed barrel crimps, and that's a huge game changer. So um, whenever I'm splitting a wire into multiple wires, we you know strip them all back the same length so that you can line them up, get them all you know butted up together so that they're all going the same direction. Slide the connector over the one side, crimp it, heat shrink it so it's the other wires are protected from its cutting, and then bend it so that there's one wire going into it from one way and the other wires are going out of it the other way, and then tape that up so you've got some strain relief at that location. And since I've been doing the closed barrel crimps like that, I'm not aware of any of them that have ever failed inside of a harness. Um, I think everybody probably has an experience where you've brought 5 or 6 ground wires together, um, crimped them with like the Harbor Freight hydraulic crimper into a lug or something, and then later on you've got a ground problem with one of them. That's a good example of how the closed barrel crimpers fix that. 'Cause you actually use the same thing for the for the ring terminals.
Yeah. Oh, I mean, we do tug tests, and they pass the tug test, and you slam it in the car, you bolt it down, and you drive a couple of events, and the next thing you know, you don't pass the tug test anymore.
Yep. Yeah, it's really interesting how important a good quality crimp is. And like to that end, if you're new to this, you should probably, you know, do some crimps and then try to pull the wire out, like each of the wires as hard as you can. Then you realize, oh, it was really important that I had them all flush and that one of them wasn't only halfway in, because when we crimped it, now it's only a quarter way in and it wants to come out. Or
Mm-hmm.
did we crimp that tight enough? So, crimp one, pull on all the wires, put it through the bandsaw and have a look at it from the end and see, is there air gap still, or did everything get squished down together? Because it's all like copper and tin, right? So it will crimp into a solid, void-free mass if you've done it properly. And um, yeah, every other way of doing it is really just asking for trouble. The maybe some exceptions to that would be, drain turning a drain into a wire. Use the heat shrink connectors for that. Or like the heat shrink solder connectors, I should say. Or if the wire is, if the wire is big enough that you actually have to go to a crimped lug or a bolt-on lug or something. But almost every connection that we make, any splice, anytime we're bringing something together, or anytime we're using a ring terminal, it's always the closed barrel terminals.
Okay. So you talked about the using relief wire or whatever to give some slack in the joints or in the terminals. What are some best practices with doing that?
Yeah, so like going back to those splices. So after you make that splice, what you want to do, so it's, you're going to have 20 wires coming into a junction, then you're going to have that splice, and then you're going to have, 3 sets of 10 wires coming out of the junction probably, right? And what you want to do is position that crimp, either inside the wire bundle, if you're one of those really big planning concentric twist guys, which I'm not, or it's on the outside of the bundle, but you pull it back a little bit and then you Kapton tape the whole thing up so that the wire that goes into the splice that has to make the 180-degree corner isn't able to pull on the splice no matter what you do with the harness. And then, you get into a lot of the same stuff inside the boots. So when we make an Autosport or a mil spec boot that we're gonna put a glued, or a mil spec connector or an Autosport connector, we're gonna put a glued boot on the back of it. Depending on, the use, the kind of car we're building or whatever, we'll put strain relief loops coming out of the wires before they go into the terminals, or we'll just glue one side of the boot on, shrink it down, and then push the harness kind of up into the connector a little bit before you glue the other boot on, so that if you do pull on the harness and the boot gives a millimeter or so, the wires have the 5 millimeters of slack that you kind of pushed in before they come out. And then on open connectors like a DTM connector or an OEM connector or something like that, there's a little bit less you can do. So if I'd say like 50% of those kind of connectors, they have a built-in strain relief, like the second crimp that goes over the weather seal. That's kind of what that does as a backup. And then there's just, planning your wire routing to them so that it's not getting pulled on the way when it's installed. Making the wiring, half an inch longer than it needed to be so that it's relaxed when it's installed. And even when we're not booting the connectors, I'll still SCL glue the end of the heat shrink so that up to that last little bit, if you pulled on it, you're pulling on it as a whole unit. So it's going to be stronger if you're pulling on all the wires together as opposed to just one.
Okay. So I have a question. I've heard this as a rumor, but I've never done it in practice, and I really don't see the OEM harness, because that's what I've been doing for the last 2 days. Do this, but running your power wires away from or shielding them from signal wires or anything like that.
Yeah, so my
Have you run into any?
my understanding
Go
is it
ahead.
only matters on certain kinds of coil systems where you're getting a lot of noise fed back through the power wires for the coils. Um, I'd have to talk to one of the even more advanced guys than me to give a better answer than that. Tim Witteridge explained it to me one time, but the gist of it was it doesn't matter for anything that I do. So yeah, I don't separate any power stuff. We do, if we're running two bulkheads, yeah, I'll put all the power in one and all the signals in the other. But that's more about pin size, because the powers are typically going to be running bigger wires than the signals. But I've never personally experienced any interference from running power, even running the battery cable right beside the harness or anything like that.
Okay. So here's another question I have. I because I'm colorblind, and I get people who are like, "Oh, you need this brown and white wire with the green wire for this
Oh no.
two wire plug," right? Uh, I prefer, one of the reasons I went to an aftermarket harness, not now, but with the previous cars, because of labels. But then I found that when it gets into the bundle, the labels have disappeared. Actually, they only label by the connector. Um, is that just the standard practice to do?
So they probably actually only labeled by the connector to help them with install. So some people build harnesses like that where they only use like a couple of colors, and once they
Mm-hmm.
put the wire into like the bulkhead that feeds the harness or the connector that feeds the harness, they put the ident tags on the other end of the wire so they know what that wire is when they're pinning it out. Um, so that's probably why you're only seeing them in the one spot. And I personally just use a different color for everything because I'm not colorblind. So I, I I'm sorry, I don't know how to relate to that one. There there's definitely it's definitely going to be hard to identify wires in the harness unless you do something like there. I don't know if you've seen the Instagram ads for the companies that'll print onto your wire for you.
Mm-hmm.
Probably that's going to be the only way to get a good harness made for someone in your position. That's going to be troubleshootable at any different spot um, without colors.
So, before I go off the rails, do you have any other best practices for us amateurs trying to fix wiring or make our own harness? It'll probably take us a year, but
Yeah. Don't solder stuff. Um, you know, I don't know why that's a point of debate, but every time I've ever seen a solder in a wiring harness, it's been the problem. Um, the other day, it took us 7 hours to find a problem where somebody had soldered the wires onto the back of the start button in a Lotus because they couldn't figure out how to take the connector apart to get the button in and out of the little piece of plastic that breaks all the time. So one of the previous owners had switched his plastic, put the button into the new plastic, and then soldered the wires on the back. And if you put a multimeter across them, they work. If you push the button, you get zero resistance. If you measure 12 volts coming out of it, it worked. You measure 12 volts at the relay it feeds, it looks fine. Except for every time you push the button, the starter would go click, 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 click. And so we changed the starter, we changed the power wires, we changed the wires from the button back to the relay, we changed the relay. Um, and then eventually we ran a 12 volt wire from the battery to the start button, and then from the start button back to the relay, and then it worked. And so we started isolating the problem and realized that it was we pulled a cover off the back of the start button, saw the solder in there, and realized that when current went through those solder joints, they got a little bit hot, and then they would lose continuity. And so the click 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 that the starter was making wasn't your normal starter problem. It was actually the relay that runs the starter closing, pulling current, and then the voltage drops, it opens, and then the current drops, and then it closes, and then it would just in a cycle like that. So, soldering stuff, if you're not going to, do a really good job, function test it, and then pot it, like epoxy it all up and then strain relieve it, that's a great thing to do. But any other kind of soldering in a wiring harness is definitely asking for trouble.
Yeah. I don't know. 20 years ago, soldering was the cool thing to do. And within 2 or 3 years, everybody was having problems.
I wonder if
They would
was stuff like the DTM circular connectors maybe not as available back then or something? Good.
Oh yeah, there weren't very many 20 years
Yeah,
ago.
so I could see if like trying to buy the right trim tool for every terminal was unattainable, it would make sense to solder.
Right, but then epoxying it, the solder is it's just a sort of metal joint, right? It's vibration prone for sure. That because anything that gets in there while you're burning it all up, it just makes an area for it to crack and break, right?
Mm-hmm.
So you have to glue it together with the epoxy if you're going to do it, and it definitely needs strain relief. I strain relief all sorts of stuff that doesn't even need it because I don't want to deal with it.
And you definitely
in different
need
ways.
to make sure that the solder joint is good too, right? So you need to heat up everything enough that the solder is flowing and it doesn't I forget, it was like cold fuse or whatever they call it, where it doesn't get the shiny finish after. Um, it's a lot easier to make a mistake doing it is kind of half the reason not to do it.
Yeah. I mean, we're good at making mistakes, and that soldering just makes it too easy to make mistakes.
Yep.
So there's a time and a place for it, but I would keep it out of your race car as much as humanly possible.
And I've had like a guy that many people would consider to be one of the best wiring harness guys in the world do a field solder that failed an hour later because it's just not easy to do a good job down in a connector, standing awkwardly or whatever.
Oh yeah, absolutely. I mean, it's one of those welding upside down under a dash,
Mm-hmm.
right? Like it's never fun,
Yep.
right? And it's similar, right? You're adding heat, you're adding filler, and you're trying to join these two or more.
Yeah, and you gotta hold them still while it hardens. You gotta make sure that they weren't dirty. You gotta make sure they were only touching the terminal you wanted them to down in a connector that's really small. So it all adds up.
Yeah. Yeah. Absolutely adds up. So you have any more best practices for us?
The other thing is when you're getting started, spend a little bit of time just twisting the wires up a little bit nicely before you try to pull them through heat shrink. That's not saying like concentric twist everything from your first harness. We're not building airplanes. It's just a race car. But if you get everything lying kind of smooth, you get a little bit of alcohol on it, you'll be able to pull it through a lot smaller of a heat shrink, which is then going to be less money and less weight and less size. So it's a nice help.
Okay. So I actually want to hear this from you. We have the new thing for 2025. What is your favorite or best racer excuse you've heard for not winning, hitting the lap they wanted, whatever?
Oh man. Why didn't you prep me for this? I could have come up with a better answer.
Well, I mean, we could take some time and edit it out if you want. That's not a big deal, but I try not to prep.
That's fine. For like just the dumbest excuse that I've personally had recently is that I've been winning a race by enough that I start daydreaming and I just drove off the fucking track for no reason at all. Oh, sorry. Can I swear? I don't know if I can swear. Yeah,
That's fine.
I just drove off the track like, oh, forgot to turn, whoops, and popped the tire and didn't win. So that was kind of embarrassing.
Yeah, that's a new one
Uh-huh.
for me. I don't think I've ever been in the position where I can daydream on track.
Yeah, so I've actually said this to customers before. They're like, "Well, go out and drive the car at 6/10 or whatever." I'm like, I don't know that you want me to drive your car at 6/10. Like, I don't need to go out and try to break a record with it, but I feel like it's a lot safer to be like 100% focused on what you're doing, putting in a lot of effort, and that keeps your brain in the right spot.
Yeah, it also allows you to identify potential issues. You don't need to go 10-10, but 6-10 is pretty low
Yeah.
on the scale, you know.
So now, depending on
All
the
right.
feel of the customer that I get, I'll just drive the car without asking because they always want me to drive the car too slow. I'm like, no, I'll just drive it at what I think won't break it, and then where I won't make mistakes. But I stay really involved with the process.
Yeah, I that's important. I mean, we talk about every time you get behind the wheel of a car on the track to do it with purpose. You shouldn't ever, it doesn't matter if you're driving somebody else's car, you shouldn't ever do it lackadaisically or nonchalantly, you know?
Man, I
So,
love that a lot. So I talk to customers are like, should I put my fire suit on for this session? I'm like, we've already talked about this. You should wear your fire suit every time you drive a car from now on. And it's nothing really about safety, although safety is a nice side effect. It's, getting all of your stuff ready, getting into the car, sit there for 10 minutes, think about what you're going to do, and then go do it. And that whole process like really gets you into the zone versus, having an alarm that goes off 7 minutes before your session, throwing your gloves on over your t-shirt and going out there and bombing around. Those are like two entirely different experiences.
I have to agree wholehearted. That's yeah. You will not get into the zone if you are not consistent with your pre uh session stuff. You
Yep.
just won't get there. Or if
And
you do, it's more by luck.
yep. Yeah, and people don't realize like how important being in the zone or being in a flow state is when you're driving out there. It's huge, and especially like, you could actively drive a time trial car or a 20-minute sprint car, but if you're having to actively drive a 2-hour endurance race in a GTO car or something, like that's going to end poorly every time. The driving has to be automatic, and you have all of your attention on what's going on. And the only way to get there is to, like you said, do every session with a purpose.
Yeah. So Kevin, where can people find you online?
Yeah, I'm like hiding out there a little bit. So our main thing is the FastX Autosport Instagram page.
Mm-hmm.
It's FastX_Autosport. That our YouTube is the same name. Facebook is FastX.Autosport. And then I'm Kevin Fennel on all those platforms as well. And we have a website, but there's nothing on it but our email address, sales@fas-tx.com. And I guess that's going to have to be the thing we work on next is getting a website set up so I don't have to explain what it is we do to new customers every time. It'd be nice if there was a bit of a primer on there. And then
It's
maybe
helpful.
get into selling stuff a little bit.
Yeah, it could help on the sales side. I mean, but also they're still going to ask the question. Let's be real, right? Like,
That's okay.
they're always going to want to know. Yeah, but it gives you a chance to learn and meet them and tailor what their needs may be, to them. So,
Yep.
well,
For
Kevin,
sure.
I really appreciate you coming on, man.
Yeah, no problem.
Until next time, keep working on yourself, keep working on the car, and let's get faster.